Hello, ladies and gentlemen. It is my pleasure to introduce Honza Horak and his presentation called Take Care of 100 Containers and Not Go Crazy. Let's hear it.
Thank you. Thank you, and good morning. So I'm thinking, why many people are here, whether it is for the first part about the containers or whether it is about the second part, how to not get crazy. And you can then evaluate whether I'm actually still not crazy or already I am. So I will start with the classic, like I had a dream when I was a small child. And it was actually quite classic in our country, not sure whether in other countries. And when I was like 6, I was, well, on Tuesday morning every week standing behind the window and I was watching the dustmen, doing this great work, with this rounded container. They were quite really good at it, and maybe it was because of the car. I really don't know, but maybe let's do a quick survey. How many of you wanted to be a dustman when you were 6? Yeah, few, and I think the others just don't want to confess it, right? So I actually realized that my dream got real, because what I do for a living is basically that I take care of containers. And we try to make them, well, not empty, but at least to behave like so make sure that they behave well. Other than that, well, I'm also responsible for the databases, Python and Ruby, also from the packaging point of view. But this talk will be basically based on the containers that we take care of for RHEL, CentOS, and also Fedora. So actually 2 years back, I was here talking about how to create a container, basically how to write a Docker file, how to write the scripts that are in the Docker file to make sure that the container runs nicely. So this is not what this talk will be about this year. I will basically move one step further. When you already have such nice container and you basically release the first GA version, so what next? Because it's not actually easy to maintain it in the future. So when we speak about the containers, we mostly have containers that work nicely on the container runtime as standalone, but we focus always also to the OpenShift use cases. So if you know OpenShift at least a bit, and I'm sure you know, so the containers that we maintain, these are the ones that you find like by default in OpenShift if you run it and you see, for example, MySQL, MariaDB. So these are the kinds of containers. So why I want to dedicate this talk to maintaining, because I think it's quite important to understand that just writing the Docker file and the scripts is not enough. We need to always keep in mind that what to mean to maintain the container and to make sure that they are still fresh and so on. So what is the problem? Let's have an example with MariaDB. So one database basically, Upstream releases version that we kind of call like major version, like every 1 year and a half or so. And since users usually want the latest version and we need to still maintain the older version, we end up with 2, maybe sometimes 3 versions maintaining at the same time. And we don't have only one platform, only one user space. So we have containers that are based on RHEL user space. We have containers that are based on CentOS user space, like the community variant of the similar packages. And we also have Fedora, like another distribution that we want to provide the images for. So one stack, one database, MariaDB, and we end up easily with 8 variants, 8 containers that we need to maintain at the same time. And you see that the list of containers is quite long. It's actually not even full list. We have another databases, Postgres, Mongo, then dynamic languages, Python, Ruby, Node.js, and then some servers like Apache, Nginx, Varnish. And every such server or language has 3, sometimes even 4 versions. that we need to maintain. So when I was, cool, we are losing screen. What happens? Okay, maybe just a screensaver, sorry. The portfolio grows quite quickly. And when I was basically thinking about this talk, it's a spoiler. So give me a second, I will use a different cable. Cool. It was quick fix. Maybe not. I shouldn't. Good. Where we are. So so the number of containers that we need to maintain grows very quickly and to big number. And when I was basically sending proposal for this conference, I thought like I need to use some big number like 100. And then I started to count and realized that we are quite close to that number actually. So I started to be like, is it really that bad? And then I realized that, well, we are still living and, I still feel not being crazy. So I want to share, what we did and what you can also do when you maintain more than one container. Maybe it will help you to not get crazy too soon. So this is basically the overview how the Git repository looks like in traditional, like normal, like distribution. For example, Fedora. Here in this case, it will be probably similar in the other distributions. So we have some Docker files, some README file, like for documentation, and some scripts or configuration files, and this all in one flat repository. But you can probably guess that if we maintain 8 images with some differences, like different user space, but it's all about MariaDB. We will probably have many similar things or many similar scripts. So what we actually do is to have one upstream repository that we maintain, and we also run tests there, and then we only take these sources and put them into all the places and to separate the downstream repositories. So the upstream, it lives on GitHub, so you can take a look at it. And you also already see here that we have some optimization here, that we don't have like 8 copies of, for example, the configuration file or the README file. We have only 3 copies for each major version. We still have each copy for the Docker file itself. So there is still a lot of duplicity. And there is also still duplicity between the versions, right? So this is like this was like the first iteration. This is how it looks like if we expand the sources. You see the duplication in the files, and for example, these configuration files and then the scripts are in most cases very, very similar. So yeah, a lot of duplicity. So the rule number 1, well, we need to remove this duplicity. So we need to share the sources when possible. And there is another reason why we want to do it, because when we have the same sources to be used in the for all the versions, we can also ensure that when user runs MariaDB 10.1, it will be the same experience as if he runs the MariaDB 10.2, which is what we want actually. So if we would maintain the sources separately, we could easily introduce some differences in the experience as well. So since the versions can be slightly different, we can sometimes go to the situation when there are some things needed to be done differently. So this is basically how we solve it currently. So some conditions like this allow us to make the source history be the same for all the versions. Where we can't do this is the Docker file itself, because the Docker file is something like the bash script, but it doesn't really behave like a bash script in these senses. So in this case, we still have the different content of the Docker files for different versions. So the rule number 1: make the scripts to be the same for all versions and keep the changes only in the Docker file. So for example, even for, well, if I can go back, for example, the MySQL version, that's the environment variable that is defined in the Docker file because it's different for each version, and then you can use it in the scripts and behave differently on different versions. However, well, having the scripts the same and have 3 copies of the same script, it's not really like the perfect state, right? So what we really need to go to is to have 1 copy of everything, not like 3 copies of the same thing. It's not like the same. So what we also did was changing the structure of the Upstream repository. From the left side, you see that how it looked before, and on the right side, you see that we moved the same parts into the common directory. Well, some people might already see some tricky part here, because when you go to the 10.2, like to the directory where the Docker file lives in, and you run docker build, and you give the current directory as the building context, which is necessary for building containers using docker build, it will probably fail because the Docker needs to work only with the files that are within the current context. So you can't reference the files outside of the current directory if you specify it this way. The fix is very simple. You just need to use the context of the directory 1 level up. So even if we are in the same directory where the Docker file lives, we need to give the docker build context of 1 directory up. Quite easy. Again, another tricky point here. You need to, in the Docker file, you need to use the version if you want to work with the files that are actually specific for the particular version. And then when you take this Docker file and don't want to change it, which is like good thing, not to change something and introduce downstream changes, you need to do another trick, create a symlink to the same directory, so the Docker file still works even in the dist-git in the downstream repository. So that's the first line. If we just copy the same file of the same Docker file, and we need to reference these, so it will work this way. Quite new thing also for us. We start to experimenting with this. It's not yet deployed fully. We have like just a good idea how to do it and some pull requests that are almost ready. It's, well, we try to get rid of the duplicity even in the Docker files, basically, and other files that we can't get rid of the duplicity otherwise. So, for example, the Docker file, if you see the changes, they usually change in the from section and what packages we install, and maybe some environment variables. And this all can be easily templated. Like, we use templates and then some variables that just will be expanded. So we have, as I said, we have a proof of concept for this. In the end, it should look like this, like have 1 copy of every file. That would be like the perfect state. And then few YAML files that will define just the values that will be expanded. The pull requests I mentioned are here as well. You can take a look at them. It's not anything complicated to like understanding. But what is the tricky point here is that when we speak about the sources for containers, they are not only used for building the containers themselves, they are also used as a documentation, because when somebody has problems with the Docker files and scripts, it's the easiest thing is to take a look at the sources, what is happening actually when starting, for example, the Postgres daemon. There is also the README file that is currently like good source of the documentation on the GitHub. It's referenced in many places. So if we want to use the templating even for the README, we will probably lose this thing. So of course there is one idea that we can still keep the generated files in the GitHub as well, but it's also not perfect. So there are some issues with this approach as well. We would like to try it and see the feedback whether we will use it for other containers as well. Well, who likes GitHub? It should be Git submodules, not GitHub submodules. Who likes Git submodules? One, two hands. Yeah, that was what I expected. Like, yeah, there are sometimes troublesome, but I must say that they work pretty nicely in our case. I think it's because we use it only for a limited set of things that we want to share across more repositories. So this is the way how we can, for example, share these building scripts not only between more versions of the same for example, database, but to share the scripts between all the repositories that we maintain. And since it's all like libraries that we seldom change the behavior but even if we do, like since the Git submodules reference particular hash, it's not really a problem to change even the behavior of this. So yeah, as I said, it's working quite nice for us. So another thing, another way how we can avoid the duplication. Recently, we also wanted to share something in the images themselves and also across all the portfolio that we maintain. For example, we have few scripts that are basically necessary for all the containers. We have few packages that we want to have in all containers. So we basically started to use more like the layering architecture that container runtimes are based on, generally. So, for example, in case of Python, we see that the Python itself is like the third layer on top of the base image. In the first layer, we have all the things that we want to have in all containers. In the second layer, the intermediate container, there are few things that we want to have only in the language runtimes. And this not only saves us some maintaining troubles, it also saves the disk space on users' end machines, So it has also another advantages. Well, it has also some disadvantages, because if we, for example, rebuild all the portfolio, we need to, rebuild the containers in good order. And here I would really like to mention the systems that we use, like OSBS, which currently has a really fresh feature, chain rebuilds. Then there is another project that can help with rebuilding FreshMaker, all available on GitHub, and should be working soon in, for example, Fedora infrastructure. And if you maintain like more than one or two containers, it's something you should probably take a look at. So OpenShift build service, as the name suggests, it's based on OpenShift, which is basically designed to build many containers, and there are these problems already solved. And yeah, it's probably good to take a look after each rebuild, which base image you chose. So when I compare what is it about to maintain package and maintain an image, it's very similar thing, except the RPM spec file, you maintain the Docker file, basically similar thing, but when you maintain images, you do builds very often, much more often than when you maintain packages. So after build, you probably want to know whether it still works. So something very important, and this should be probably like half of the presentation, but it's not because there will be different talks about this topic on this conference, so I wanted just to mention this quickly, but it's very important. Like, if you maintain some image, don't depend on any manual tests. Have everything automated. We use Jenkins for this. We test every pull request, so even before it's committed, after commit again. And yeah, maybe just a quick note that we try to have some quick feedback using the container runtime itself. It allows us to see some quick results very quickly, and then we have some more complicated use cases using the, for example, OpenShift quick starts. Again, everything visible on the GitHub and in the Jenkins, like this CI CentOS org. So 2 takeaways from this presentation, if you remember only those: avoid any duplication if you want. That will save you a lot of time, and automate tests and run them as much as possible. That was all. I'm not sure how much time we have for questions, but do have some. We have like 1 minute, so maybe, yeah?
Yeah.
Yeah. So the question was, when we had different folders for each version, whether we considered this is visible here, whether we consider different branches. Well, we did, and well, we actually didn't try it in practice, but we thought like it would be much more complicated when we want to, for example, have a pull request for all the branches. So it would be probably four pull requests. So it would be probably very hard to contribute to it. We could cherry pick. That's a good comment. But again, we still want to have only as simple pull requests as possible. And since we know that there was a lot of duplication that we wanted to get rid of, in the end, we wanted to get something that is visible on the right, like to have 1 copy of everything rather than more branches. Thank you.
Okay, so this is all we have time for. So thank you very much for your presentation, Honza. It was very nice. One final round of applause, please.
Thank you.
The next presentation is in 6 minutes.